So, here's the Hudson. We haven't crossed the Hudson yet. We're right near the Hudson crossing, so we're kind of like in here.
Is that the bridge?
That might be the bridge right there. Yeah. So we're like over in here. We'll cross over and we'll visit this sort of area. We're going to cut across this way and then sort of down a little bit. So when you're looking at the map, that's essentially where we are. And I think the one that's online, I boxed out the area of what we're looking at. So if somebody wants to kind of hold that, kind of take a look at it. So we're in.
Put a rock on it.
This is part of what's called the Taconic region. Oh, good idea. This is the Taconic region of New York. So if you looked at the map, you'd notice there was the Adirondack region, the Taconic region. So this is the Taconic region, and it's basically dominated by rocks, primarily from the Taconic orogeny. So remember, there are three major orogenic events: the Taconic, the Alleghanian, and the Acadian that we talk about in this area. We talk about as we go out to the Delaware Water Gap. So you're talking about Middle Ordovician time, somewhere around 445 million years ago. So this event here, that part of the Taconic orogeny that we're going to look at here, is also an influence. Remember, we were talking about in class, if you go out to the Delaware Water Gap. So you don't see the intense metamorphism that you get in this area, more towards Connecticut, but you get a lot of the folding that's associated with a continental event. So basically what was going on in Middle Ordovician time, you have the Proto-Atlantic is essentially closing up. And there is, at that time, you get a rupture offshore that caused a part of the crust to essentially thrust. It was the western part of the crust thrust underneath the eastern portion of the crust. So you have the Atlantic is essentially closing in, right? Because you have a mountain building event. So you have the western edge essentially. I'm sorry, I'm putting my hands the wrong way as I'm facing eastward. So you have the western portion of the crust essentially thrusting underneath the eastern portion. And so what happens is you start melting then that rock because you're thrusting something underneath something else. So you start partially melting that crust, and that forms an island arc. So you have essentially magma that begins to come up from that partially melted crust, and you form this island in between where these land masses are beginning to come together. Go about 10 million years later, that island is now being smashed up against the continent, and the ocean basin is essentially consumed. It's closed up at that time. So in this 10 million year period, as the Proto-Atlantic is essentially closing, crust is being thrust under more crust, you're melting it, you've got this island arc, but plates are still continue to close and close and close. Now we weld that island arc right up against the edge of the continent. So we're continuing to collide those plates. So what did we get? As the result of that, we essentially get the rise of the Taconic Mountains. So that's the Taconic orogeny at that time. You get the Taconic Mountains. You have a lot of thrust faults that are westward directed, so things that are thrusting this way. If you go out to the Catskill region, there's what's called the Hudson Valley Fold Thrust Belt, which is really cool. You see all these thrust faults, and it's essentially, you see the one set of rocks essentially being thrust up and lying over the other set of rocks, and it's this huge outcrop along one of the major highways. So you see a lot of thrust faulting in this area. Lots of landslides, very intense folding, intense faulting, and then of course metamorphism, which is what we're going to look at. So Jimmy, just picture these land masses slamming against each other, and you're going to get all of this very dynamic change. So what we're going to do is we're going to look at that resulting metamorphism from the Taconic orogeny. That's what we're going to see on the trip. What did we get as a result? We're going to see folding. We're going to see faulting over here. We're going to see a lot of these other things, but we're really going to take a look at what the rocks look like, and you'll see a progression in metamorphism as we move. If you looked at the map, as we move from our area where we're just about at the Hudson River, we're going to come out and we're actually going to go over the Mid-Hudson Bridge this way, and then as we traverse this way towards the Connecticut border, you're going to see that increase in metamorphic rate. So before I say anything about these rocks, what do you think? What do you think is the rock type that you're looking at here? Who wants to venture a guess? I'll give you a hint. You saw all these rocks in class.
Yeah, it was the beginning. It was the
Shale.
same as A that we saw, like slate or protolith.
Right.
Yeah.
So you're at the protolith. You're at it's essentially, well, one thing. Let me say, it's not the protolith. It's what is a very likely protolith for what the rocks were that were metamorphosed. So it's not directly correlated to the rocks that we're going to see, but it's a very good representation of what that protolith is. And essentially shales, interbedded sandstones and siltstones and shales. And you can kind of see that if you get closer up, or even as you're standing back, you can see that some of the rock is coarser grained than the others. You can see some of it's more sandy, some of it's more clayey. What this unit is, it's essentially an outcrop of what's called the Austin Glen, A-U-S-T-I-N, and then second word Glen, G-L-E-N, and it's part of what we call the Normanskill Formation. So it's the Austin Glen member of the Normanskill, Normanskil. They are slightly metamorphosed, but they still really retain their sedimentary structure, their sedimentary bedding, and that sort of thing. And so you can see it. I mean, if you get up close, you're going to be able to look at some of the bedding. But what you're also seeing as you look at the rock, you're seeing some of that folding. You can see these rocks are not flat lying, right? And original horizontality says that these things are originally flat lying. So you can see evidence of that mountain building event. You can see some of the folding in it. You can see dips of the angle. What I think is going on with this weird star, it looks to me. Come run, Helen. As far as I can tell, I mean, you look like you have more of your shales and siltstones in here, coarser grained sandstones in here. You see this spot that goes up here? That looks like a faulted area. So if you look at the bedding on this, it almost looks like part of this is kind of rotated. The best guess I can come up with for what this is we're looking at results of a lot of that folding and faulting. And sometimes you get rotation of rocks when you have all of that intense activity going on. That's what it kind of looks like to me. I'm not sure why the hole in the middle. It may have something to do with when you get faulting. Now I'm not a structural person, but you get, am I in your way? You get what we would call different order faults. So it's almost like you get the big fault, and then within that fault, you get other faults and other faults and other faults. So I think what you're looking at is multiple orders of faults. You get the same thing with folds. You can have, we're all smiling. You can have the big fold. So picture the Delaware Water Gap region. It's a big folded area. But within those folds, you can have second and third and fourth order folding in between. And I want to say, Dr. Becker said, whatever place you went to recently, you saw multiple orders of folding within the rock. Somewhere you just went.
We went to Allentown Formation.
Allentown, yeah, and then the other one.
Towards Riverdale, we saw
That one.
Park.
that was fault that had the folding in it.
Right, and you saw
Yeah,
multiple orders of folding, correct?
Yeah, the folding in it. We're both faulting.
Right. So that's what I think is going on here. Is you have an area that you have intense deformation. You're probably getting multiple orders of faulting and folding going on. That would be my guess. I'm kind of interested to know exactly what it is. So I like this outcrop a lot because not only does it show you like, okay, sure, this is what it would have looked like, but you see the result of, well, even when things are not metamorphosed, the rock is still very much changed. It's intensely folded and faulted in this area. So it's kind of neat. You can see the differences in the shales and the sandstones. Something else I want to point out, but you have to step back. And it's something you're going to see, and I think I'm going to give you a hint in the next outcrop, so if you can pick it out. there's a particular type of folding called chevron folding. You know the chevron symbol? The picture for chevron? That's like this, almost like this pointed thing. If you look right up, see under that set of trees, right below it, you see how it's like this? And you see how these right here are like this? They look like very sort of large-scale chevron folding. I want you to remember that shape and see if you can see that in one of the other outcrops. I think it might be the next one that we see that chevron folding. And it's something that we see a lot. So you see very evident the types of deformation that you get with these tectonic events. Is this contact or regional metamorphism in this area? Regional, right? So we're talking big mountain building events, orogenic events, affecting a very large scale. I mean, we're going through Dutchess County, crossing essentially the state of New York, continues into Connecticut. So very, very large scale that you're looking at, and you see that even in the outcrop here. Do you guys have any questions for stop one? Anything you want to look at or photograph while we're here?
The small layer is so brittle. It's just not very normal. It just breaks apart.
Yeah, because a lot of it is weathered. You know, you've got the weathering on it too. But these types of rocks are they're gonna weather down much more easily than the other rocks that we look at. They're gonna get even more and more resistant.
As we get further down, they're more resistant.
Yeah. What do you think about the minerals? What do you think? Now that you know for certain what we're looking at, what do you think?
I don't know.
You walk into that one.
Yeah. What was your question?
I don't know. Dan was asking me, so I'm not sure.
Well, let's work through this question that nobody wants to take credit for. The question was, are we going to see any minerals? What do you expect if you know we're looking at essentially shales and siltstones, some sandstones? Probably not. Does it mean that there's no minerals in there? No, but what does it mean?
They're small grain.
Yeah, they're very fine grained. So yes, there's minerals in there. If we are able to run X-ray diffraction, I don't know if we're going to get to fit it in. You could tell some of the mineralogy of it. If you put a thin section on the microscope, you can probably see some of the mineralogy in these. So yeah, sure, there are minerals. Can you pick it out in hand sample? Might be a little bit difficult.
Later down the line, we should be able to, right?
Absolutely. So some of them you're going to use your hand lenses are going to help you, and some of them towards the end you're just going to pick it up. And you're going to go this and this and this and this and this, and you're going to pick them out right away. So.
Wait, on some of the pieces that we picked up in the shinies, that's not like this?
It could be, yeah. Overall, what I'm saying overall is it might be a little bit more difficult to tell what the mineralogy is because you don't have anything but your eyes, essentially, in your hand. But yeah, if you see, mica is usually very easy to pick up on because it reflects the light really nicely. So yeah, some of those
But
small
there's not a
things.
lot of it there.
Right, and it's probably muscovite because we haven't gotten into the biotypes of the biotypes. So we're not even
I should have brought that short.
Any other questions on this stuff? All right, you ready to head to the next stop?
That's a road cut that was cut through between this shop and that.
It must be, yeah, that's my guess. Or, well,
Is it different?
no, it may. I'm not sure.
Dan,
I want to say that's similar, but I'm not sure.
for a point of reference, you know, for
Oh,
scale,
on
scale,
that.
yeah.
Dan for scale.
Yeah.
Somebody's,
Oh, that's point over.
Don't lose your stuff. Oh.
Ziploc and a Sharpie to label them, then this way you won't forget which comes from which stop. I have them in the back of the truck.
I just took a pencil and ruler.